Okay, so luckily, yeah, last time we did most of the heavy lifting when we were talking about simplifying rational functions. Now we are going to continue on our pages 97 through 99. We talked about just simplifying a single fraction last time. So today what we're going to add to that is talk about simplifying when there is multiplication or division involved. And then on the next one, we'll talk about addition and subtraction. I like to do multiplication and division first because they're a little bit easier with fractions because I don't have to have a common denominator. So the big thing to remember when we are multiplying and dividing, so still number one is I'm always going to factor. After I factor, when I want to multiply two together, I really don't have to think any further than that. When you multiply fractions, you just go straight across the top, straight across the bottom. And so I can just start canceling stuff like right away. So we always cancel or divide top to bottom from any fraction. So we just kind of smush them together and start dividing out. It's a real fun time. The tricky part can be division because we don't really divide fractions. So we go straight to canceling our factors with multiplication. However, before I can do that with division, I need to keep, change, flip, or multiply by the reciprocal. So we don't really divide fractions. We want to instead multiply by the reciprocal, or keep, change, flip. Okay, and then we can just start canceling factors. Now, after we cancel our factors, then we sort of just multiply straight across. And we want to hope, again, that there are no more common factors to divide out. And then we always set our restrictions at the end. So that's when we say, okay, x cannot be this. Okay. So again, we've done most of the hard stuff. We know we have to factor first. Then it's just a matter of multiplying or dividing. So let's try some. So on page 99 here, I kind of put my book towards the top because I'd love to put addition and subtraction right below it. Because again, we don't have too much that we need to talk about here. When we multiply a rational expression, we need to factor, then multiply straight across. Now, when I put multiply in parentheses, we're not actually going to multiply. We're just going to smush everything together. Because if we factor it and then we re-multiply it, we kind of undid what we just did. Now, with dividing rational expressions, we still want to factor. But then we want to change division to multiplication. And then flip second fraction. And then just go back and do what we did here. So yeah, let's just do it. So looking at example 1, this first one here I can tell is multiplication. So we can right away just multiply our numerators. So we get 18, x to the 5th, y to the 2nd. And then in the denominator, we have 8, x to the 4th, y to the 2nd. And then I can start dividing because all of this is just straight up multiplication. There are no pluses or minuses, so no need to worry. So with the 18 and the 8, I can divide out a 2, so 9 and 4. With the, I should have used a different color here, I will. With the x to the 5th, x to the 4th, I can divide out all 4 of these from here, but there will be 1 left on top. And with the y squareds, they will completely divide out. And so overall, in my numerator, I have 9x. In the denominator, I think I just have a 4. And because there is no x in the denominator, no need for any restrictions. Okay, so looking at the next one, that is also multiplication. However, there are these parentheses, the exponents on the outside. So we do have to do a little bit of distributing here first. So like 2 to the 4th is 16. Then we have x to the fourth, y to the fourth. Denominator is not part of that parentheses, so it stays the same. So this one is also the negative first, which the first power is not going to change anything, but a negative power flips everything. So we actually are going to flip this fraction. But all the exponents stay the same because a 1's not going to change that. And so then now going up here, because we're multiply, we can just multiply straight across. So new numerator will be 16, x to the 7th, y to the 4th. Denominator will have 4, and then x to the 3rd, y to the 3rd. And again, because we're a big old multiplication problem here, we can just start dividing out. Gotta use my other color. I messed it up. So like the 4 and the 16, I can divide up 4 out for 4. With the x's, we have 3 on bottom, 7 on top, so 4 will be left on top. And then y to the 4th, y to the 3rd will have 1y left on top. So, oh, I think my denominator is fully gone. Yeah, it's just a 1, and I don't need a 1 on the denominator. So my numerator is just 4x to the 4th y. And again, no denominator, so no need to worry about restrictions. Okay, let's do C right. So for C, we are also multiplying. However, these things have not been factored. So we need to factor first. So the numerator for this one, we want to do an x puzzle. So I think that's going to be plus 5 and then minus 3. My denominator has 2 terms. It's got a 5 in common, so I'm going to take a 5 out. So then we'll have 3 minus x. Ooh, those are similar. But the 3 here is negative, the 3 here is positive. And the x here is positive, x here is negative. So we can kind of do this clever thing where I take out a negative 5 instead, and that'll change both these signs. And then I think it is the same as this. They're just in an opposite order. Sneaky stuff. Now that is being multiplied by the 10x, which I can't really factor that anymore. That's already multiplication. And the x plus 5, and I can't really factor that anymore either. Now again, because this is a multiplication, we can just smash these two things together right now. And so I'm not going to really rewrite it because it's already sort of smashed. I just want to start dividing out factors that are the same. So like in my denominator, I had an x plus 5, and I have another one in the numerator. So they can go. I did this sneaky thing where I took out a negative to make these two the same, so they can go. And then I have a negative 5 with the 10 that I can divide out for a negative 2. And then our x is still there. So again, I think my full denominator disappeared. Numerator is just negative 2x. And again, no denominator, so no need to restrict anything. Okay, last multiplication problem. I didn't even realize we're just multiplying here. LOL. So we are not factored on any of these yet. So I need to factor all 4 of these. So this first one, those are some perfect squares. So we're going to be x plus 2, x minus 2. The denominator, trinomial, so like what x puzzle, so like what multiplies to 4 and adds to negative 2. And I kind of don't think anything. So like I'm going to have to look for a trinomial factor, hopefully in my numerator somewhere, which I think will actually happen because I noticed right here I have perfect cubes. So that is a binomial, trinomial situation. So that's x and 2. We square, multiply, and square. Signs go same, different, positive. So yeah, I do get that trinomial, which is real nice. Now, in the last denominator here, we have 3 terms. So we're thinking what multiplies to 4 adds to 4, and that's 2 and 2. And now that everything is factored, I can smush them all together, but to me they already look smushed. So I'm just going to start dividing stuff out now. So like working through my denominator, again, I'm looking for this trinomial here, and luckily I had it so they can fully divide out. I'm looking for an x plus 2, which I have. And then I'm looking for another x plus 2 if I have it, and I did. And so it's so satisfying to like cancel all the things. And so the only thing that's left is in the numerator, and it's x minus 2. And again, no denominators, so no restrictions. Okay, division. So here's where we have to be a little careful because we don't divide. We instead multiply by the reciprocal. So for A, everything here is already all smushed together. There's no pluses or minuses. So I'm going to keep the first fraction the same. But then I need to change this to multiplication, and I need to flip my second fraction. So 54 is coming up top now. Now, and the last one that I had like this, I multiplied everything together, but I kind of don't want to here because like 16 times 54 is going to be absolutely no fun. So because everything's already multiplied, I can already just start dividing stuff out. Like I noticed that the 81 and the 54, like 9 can go into both of those. So I'm just going to start dividing stuff out. So 9 goes into that 9 times, and 9 goes into this 6 times. Ooh, and I can divide that again. Oh, 3. I didn't even realize. So 3 twice, 3 times. Okay, cute. Now I can divide, well, I can't divide the 3 and 16 because I don't have anything. But I could do the 2 and 24 for 12. And then I could do the 12 with the 16. So I can't do the 12 and the 3 because they're on the same level, but I can always go top to bottom. So like the 12 and 16 have a 4 in common. So 3 here and 4 there. And so I think I've done all I can with the numbers. 4 and 1 on top, 3 and 3 on bottom. Yeah. Okay. That's kind of a mess. I'm so sorry. Then we can go with x's. So I have an x squared here and an x squared there, so they can like fully divide out. Then I have this other x and an x to the third. So we're going to have 2 left on top. Then with the y's, let's see, I have a y on top, y on bottom. But then I have a y squared and a y to the third. So 1 left on top. What a humongous mess. Okay, let's try to figure out what I have left in my numerator. So my numerator over here is a 4. No, so the numbers are 4 and 1. The x's here are fully gone. So just a 4. And then over here we have x squared and y. Denominator, we had the 3 and the 3, but I don't think any letters. So 9 overall. No letters in the denominator, so no restrictions. So honestly, I think it's actually easier when you get to factor because this is kind of a whole mess versus something like B. So B, because I'm dividing, I want to take care of that first. We're going to keep the first one the same. And like while I'm thinking about it too, I can't even really factor that because 4 and n are already multiplication. There's no addition or subtraction. And n minus 6, I can't factor that any further. They don't have anything in common. Then I'm going to change that to multiplication, and then we're going to flip this. So we'll have 8n minus 48, which I can factor that over 4n, which is the same as this. So I can already see I can cancel some stuff. Let me factor this first, though, because we always want to factor first. We have our 4n, n minus 6. And then here we can take an 8 out, right? 8 goes into that. 6 times? Ooh. Okay, so our 4 can divide out with the 4. The n can divide out with the n. Now the only other thing I have in my denominator is an n minus 6, and that would have to go with another n minus 6. And luckily I had one. And so super satisfying again. Everything cancels out there except for the 8 in the numerator. So just 8 overall. So that I think is much simpler than this whole mess. And so last but not least, we got to factor all these. And we got to change that division. So first here, I can factor by taking out a GCF of 2x. We have x plus 2 left. In the denominator, I have perfect squares. So x plus 2x minus 2. Then I change this to multiplication. And I'm going to flip my fraction now, which means that 3x minus 6 is going to go on top. So I hope this is not too much, but I'm going to factor it at the same time. So like they have a GCF of 3, and then we'll have x minus 2. Then I need to do my x puzzle here. So I'm thinking what multiplies to 2 and adds to negative 3, and I think that's negative 2, negative 1. So x minus 2, x minus 1. And now because everything is factored, we can just, and because we're multiplying, we smush it all together. We want to divide top to bottom. So like if I start on the bottom, I'm looking for an x plus 2, and I have one on top. Then I'm looking for an x minus 2, and I have one on top. Then I'm looking for another x minus 2. I don't got one on top. Or an x minus 1, and I don't have one of those either. So it's kind of all we could do on that one. So my numerator is 6x. Denominator, I still have both these things. So like the x minus 2 and then the x minus 1. And so x cannot be some things here. It actually can't be 2 or 1 because both those are in the denominator. I'm going to make them 0. Okay, last but not least, we can add a little geometry to this if we want. But you know, I kind of don't want. So I'm going to skip it. Okay, I'll see you in a minute.